Hello everyone, our team is SYZ. My name is Steve.
My name is Yang.
And I'm Zarna, and we're here to talk about Geographic Information Systems tonight. Let's start. Geographic Information System, or GIS, is basically a system which integrates hardware, software, and data for capturing, managing, analyzing, and displaying various forms of geographically referenced information. To better understand what a GIS is, we can see in the next slide a diagram of a GIS, and it can be thought of as a stacked set of layers of maps. As we can see, each layer contains a unique geographic theme or data type, and each layer is aligned or registered to all the other layers. A GIS is most often associated with a map. A map, however, is only one way you can work with geographic data in a GIS, and only one type of product which is generated by a GIS. A GIS can actually provide a great deal of more problem-solving opportunities than using just a simple mapping tool or adding data to an online mapping tool. As we can see in the next slide, a GIS can be viewed in three different ways. First is the database view. A GIS is a unique kind of database of the world, referred to as either a geographic database or a geodatabase. As the second diagram shows, we have the map view, where a GIS is a set of intelligent maps and other views that show features and feature relationships on the Earth's surface. Maps of the underlying geographic information can be constructed and used as windows into the database to support queries, analysis, and editing of the information. As the third diagram shows, we have the model view. A GIS is a set of information transformation tools that derive new geographic data sets from existing data sets. These geoprocessing functions take information from the existing databases, apply analytic functions, and then write the results into new derived data sets. Moving on to what comprises a GIS, we have the components of GIS. The basic four components of the GIS are data, hardware, software, and the users. It is not enough to have just one of these. All components must be present in the system to have a truly fully functional GIS. They need to be integrated and working together. The first component is data, which is probably the most important component of a GIS. The data can be either spatial data, which tells us about where something occurs, about the location of something, or the second is the attribute data, which tells us the nature or characteristics of the spatial data. And a GIS must have the capability to store and manipulate both spatial data and attribute data. The next two components are the hardware and the software. We have various types of both of these available for all types of GIS. And the last component is the users. Broadly, they can be classified as system users and end users. System users are those people who have actual hands-on use of the hardware and software. They have advanced technical skills in the problem solving of GIS. End users are those persons who do not have actual hands-on use of the system, but who do make use of the products which are generated via the GIS. And we have another type of user who are called as data generators, they basically collect the raw data to be entered into the GIS, and they play also an important role in GIS.
GIS can be used in scientific investigation, resource management, asset management, and many fields. It allows emergency planners to calculate their response time in event of a natural disaster. It can be used to find wetlands that need to be protected from pollution. It can also be used to set a business location which is underserved. It can be used by a company to set a business location to take advantage of a previously underserved market. If what you do involves management of information that can be linked to geographic information, GIS will help you. The figure on the next slide shows that the migration routes of caribou in Alaska, scientists use GIS to superimpose the routes and the map of oil development plans. This figure will help scientists to study the potential effect of oil development in Alaska on the migration of animals. Then I'd like to talk about the advantages and the disadvantages of GIS. The advantages of GIS include that once a map is established in a digital format, it is easy to update it, change it, or merge it with other maps to create new ones. It provides a huge range of tools that allows for accuracy in decision making. It also displays spatially related information in a way that can be easily understood by most people. The disadvantages of GIS are the cost of data inputs is high and is unpredictable at an early stage. Therefore, it's hard to estimate the overall cost of utilizing a GIS. The input sources are of varying standards, and it may cause some errors in application. There's a lack of user-friendly interface. Some systems require knowledge of a complex command language, and it is hard to find resources and accessibility rules of the database. Then I'd like to talk about the implementation of GIS. The first step is to do a requirement analysis. The requirement analysis serves as an overall framework of the project. It defines who the users will be, what applications will be implemented, and what requirements are needed to support those applications. A successful implementation of GIS requires strict adherence to a structured task steps listed here. The output of one task is the input of the next. In this way, we can make sure that the system will meet the requirements of the organization.
Okay, let's talk about ontology from now. Ontology is a key component of a semantic approach, as it allows the specification of concepts and relationships in a given domain. This in turn allows the GIS to focus on the meaning of data rather than its syntax or structure. For example, if a tourist who lives in Japan wants to find a store in USA, probably he will search for 7-Eleven, one of the most popular convenience stores in Japan. But what if there is only BP instead of 7-Eleven in USA and he didn't know BP? In this case, ontology can provide some useful information to use synonym relationships. If he just input 7-Eleven, then ontology-based GIS system automatically find out BP based on system relations. Then how can we implement ontology in real world? Like the most recent development in standard ontology languages endorsed by the Worldwide Consortium to promote the semantic web. In general, it creates extensible markup language as a delivery. I will show you in briefly how we can create classes and relations and attributes using Practice 3.4 version editor that used editor OWL and RDF ontologies. In conclusion, GIS is a very useful tool, especially ontology-based GIS can improve the performance of searching information in the real life. Okay, any questions?